All right. Cool. We have some people joining in. So as we have folks joining in, thanks for joining us here today. Give people just a second to come in, but just a little bit of housekeeping as we're getting going. I'm sure folks are very used to this Zoom meeting type of atmosphere anymore, but as we're going along, the intention here is we really want to hear questions. We'd love to hear from the audience members, everybody that's out there. So if you can use the Q&A button, the questions and answer section of the webinar feature to submit those. That helps us really keep track of those. So use the Q&A, not the chat function. Really helps us out. And as questions come up, please send them along. So we're wanting to answer stuff as it comes up, not necessarily waiting until the very end. So with that, we will also be sending out, we're recording this, we'll be sending it out. If you have other questions or things come up, we'll have recording and then access to it on YouTube channels for both Mayfield and for Roof Tech. So I think that kind of gets us going. So we can get in, do some introductions and start talking about our topic today. So again, thanks for joining. My name is Ryan Mayfield. I'm the founder, CEO of Mayfield Renewables. I've been in the industry since '99, and we actually have some photos here, not of me, but some photos I took early on in my career. So it's actually interesting to as we start talking about the evolution of things here. But I got started as an installer. So I was up on the roof in attics doing I started off doing a lot of solar thermal as well as early PV stuff. So we are, now working in the industry through my company, and we'll talk more about who we are as a company as we go along as well. Today, I'm joined by Laurel Hamilton and Mike Dunlap. Laurel is with Mayfield Renewables. She is our technical services director. And Laurel, prior to coming to Mayfield, Laurel was working on the contracting side of things. So she has many years of experience also working up on roofs, doing installations, working with customers, looking at products. Laurel has her PV technical sales, her NABCEP PV technical sales certification, and has worked on the NABCEP panels, as a subject matter expert for the testing on the testing boards. So it's great to have her input, and I would say Laurel's has had a hand in pretty much everything that we've done, and really focuses in on quality all around. So thank you very much for joining us today, Laurel.
Thanks, Ryan.
And then we also have Mike Dunlap, General Manager of Roof Tech. Mike joined Roof Tech in 2016 as the sales manager, and then just this year was named the General Manager. And so sounds like big changes been going for Mike. And as we were talking, as we're preparing, it sounds like it's still kind of in learning as you go, I guess, a little bit. And changes are a little bit, can be difficult like that. But previously, Mike was an owner of his own general contracting business. So he's, very, and doing a lot of, we were talking before, doing a lot of work on roofs and things like that. So Mike understands the challenges of working with PV systems, rooftop systems, how to integrate things, keeping high quality installations, and maintaining warranties, meeting codes, and all those kinds of things. So great to have you join us today, Mike.
Glad to be here. Thanks, Ryan.
Yeah. So real quick about Mayfield, we are a technical consultancy, and we offer services, a variety of services. System design and engineering is the core of our business. That's where when I started the business in 2007, that's what we started doing. I was also doing education and training, and been doing education and training all along. And so that's a big part of what we're doing. And that's, these AMA series really falls into that education and training for the industry. And then we're also doing technical consulting and microgrid support. So working with manufacturers, working with contractors on consulting issues. And then we're seeing a lot of microgrid jobs come up. And so we've been working with a lot of folks helping on those as well. So happy to, if those of you out there have an interest in any of those, happy to talk to you directly. So we can move on to our topic today. And so Laurel, you want to go ahead and kind of kick us off and introduce us for this?
Yeah, so the topic today, which we're happy to have Roof Tech join us, is to flash or not to flash. I feel like this is a topic that has come up time and again for anybody that has been on the roof, and figuring out what the best solution is for maintaining the roofing integrity of your clients is really key to any system that we're touching. Nobody wants the liability both for their own business themselves, and we're really out to improve people's properties, not harm them. And so it's been really interesting talking with Ryan and Mike over the last few weeks about this topic and how it has changed over the years. And I've been in the industry for 8 years and have seen a lot of changes just in that time. So at the crux of it, we're all trying to do what's best for our clients, and just kind of wanted to bring this topic to the forefront with Roof Tech in particular, as they have been bringing a product to market that is new in some cases and really not in others. So really want to talk about, what are the code changes and why are they changing, and why are best practices changing? Yeah. So I think we can go to the next slide, Ryan, where we dig into the overall picture.
Yeah, so let's talk a little bit about the codes and what people point to. And one of the things I said to Mike and we were talking with Joe over at Roof Tech as well as we were going along. And it's interesting. Mike's got some good, interesting points on the codes as well. But a lot of times, we are working with, we're in an industry that is very often ahead of the codes and quite, electrical codes, building codes on some levels, and this natural progression. When we first started installing solar, there's nothing written in the codes for us. So we're using other code sections to, I don't want to say force the systems in, but we're doing the best we can with what we have when there's not industry specific codes. And so that's actually a whole topic in of itself. But the ones that I've always pointed to, and I think the industry as a whole has very often looked at these code sections, the IBC and the IRC, and we have our two different code sections there. But there is this language around flashing requirements. And so that's one of the things that I think has really driven the industry. And in our next slide, we kind of see this evolution of what is considered best practice in the industry. And this is one of the things that gets pointed to a lot. And I personally have pointed to this. And so I think one of the big questions is, what constitutes flashing? There's some direct language in there that talks about metal flashing, but it's not necessarily a one-for-one when it comes to our solar installation. So, Mike, I know that you and Roof Tech, you've spent a lot of time in the codes themselves. And so, how do you see this being applied and being used when you're testing the different standards?
Yeah, codes and standards is extremely important to Roof Tech because we're bringing to market, or have brought to market, such a unique product to the USA, especially. We had to really dig into this and really made sure that we were actually fitting code compliance. And where we started actually was the definition of flashing, which is in both the IBC and the IRC. And that definition of flashing is pretty vague. I'll just go ahead and read it real quick so everyone has a clear understanding. Flashing shall be installed in such a manner so as to prevent moisture from entering a wall and roof through joints or copings, through moisture permeable materials, or at intersections of parapet walls or other penetrations through the roof plane. That's it. Obviously, everyone knows here that different roofs require different types of flashing. When you get to the to the location section of that code, section 2.1, it does point out specifically about using where, when using metal flashings, it gives you criteria for what that metal flashing needs to be, thickness and size.
Right.
But there's no other definition of what those other flashings need to be. And that including weld-on products for flat roofs and EPDM flashings for chimneys or butyl flashings for chimneys. And specific to us, of course, butyl flashings for pitched and low slope roofs. So starting with that definition pretty vaguely, as you said earlier, we are ahead of the industry and the codes are catching up. And currently right now, CalSA has been a huge proponent of helping us start to define these conversations and define flashings so that we can give that information back to the ICC to put into the IBC and the IRC, hopefully in the next code edition. So we are working to adapt basically a more definition of flashing per solar specific industry.
Yeah, and I think that's one of the things that's been brought up before is we don't have an industry specific listing. We don't have an industry specific method of testing or definitions here. And so that was news to me about the stuff with CalSA. So that's great to hear that that's something that's getting moved, because that's really, I think, one of the things that we need as an industry. And, as we were talking before, it's we're trying to promote what's best for the industry. We're trying to promote what is best for the customers. And of course, there's an evolution to all that. And so one of the things, that we have to do is take the codes and standards that we have, and in some cases, do some modifications or do the testing the best we can around those.
Yeah, one other point I want to point out with the IBC and the IRC is that these books and these standards were developed for new construction and new installs, and they don't do a very good job about retrofits or remodels. So that is also something I hope that we can also further define for the specific industry, because as everyone knows, it's not all the time, or I would even say probably rare, that you actually get to install and place flashings with a fresh roof to where you actually can follow the NRCA application for how to properly install standard flashings. So I do hope that we can also work towards focusing more on the retrofitting guidelines and protocols in the future.
Yeah, and that's actually interesting. I don't think we have a slide on this, so I'll kind of just throw it in here right now. But so you mentioned the NRCA, and there's also the roofing manufacturers themselves, right? They have their own standards and they have their own requirements. And so that's also just something that has to be considered. And I know Laurel probably got this question every single time, about what's going to happen to my roof warranty as soon as I install these. And so kind of having those standards set so that all the roofing manufacturers can meet those is important.
Absolutely.
Yeah, definitely. Connection better to the roofing industry and the roofing manufacturers from the solar industry, I think would benefit everyone. I think it's better, but
yeah, we are starting to see that in real time. Definitely starting to see a lot more of the roofers actually jumping into solar installation. Right. So we're trying to keep up with that as much as we possibly can to offer solar specific trainings for these guys, and working with manufacturers as well. We were successful with Owens Corning, getting a letter from them specifically stating that our product won't void their warranty. But what we would like to see general is for the manufacturers to basically come up with here are all of the accepted types of flashing and not being so specific to manufacturer. Right.
Yeah, and that points all the way back to standards, right? I mean, if we can just get the definition and the standard set, then that would be the best way.
Absolutely.
Okay, so let's look here let's just kind of go through just kind of a series of photos here, and the intention here is kind of going through what were those best practices, how has the industry evolved over time, and what was considered good back then, and kind of how we've progressed. And so none of these pictures are we're trying to call out necessarily. We all had our horror pictures that we could have spent the entire hour going through and having a lot of fun with. But the intention here was, what were we doing, and how were we doing the best we could with what we had at the time. And so this first picture is actually, so this was one of them. I took these pictures, and these were put in some manuals of how to install L-feet for a racking system the, quote unquote, right way, the best kind of practice way. And I remember, I remember that when the Sitka Flex, and I forget the exact number, there was the manufacturer Sitka Flex for this caulking. It was compatible with asphalt shingle roofs, and the industry just was doing backflips because we had this method that was compatible. It's not going to eat away at the asphalt shingle itself, and we're going to have these 20-year connections. And this was considered the right way to do it. And so, many, there's probably, I don't know how many systems are out there that are using these, and hopefully still are in place. But it's just interesting to see, that was how we were going about doing these. And so, yeah.
What time frame was that, Brian? Do you think?
This would have been early 2000s. This would have been 2002-ish, probably, specifically on these photos that we were taking. Because I remember the person's house. I was actually one of my first bosses. It was his house. We were installing a Sharp Solar, a Sun Vista system. For those of you who remember that one, inverter with 3 MPPTs. I thought it was like the answer to everything. And so it was a fun little job we did. But so yeah, early 2000s is when this would have come in.
Gotcha. And somebody just commented it was Sitka Flex 1A.
1A. Okay, there we go. I remember the Sitka Flex. I can't remember the exact. But I remember grabbing the manuals and putting them in, or grabbing Sitka Flex's manuals and putting them in as like addendums to these documents we were writing, as this is the right one to use. Don't use anything else. So.
And, I just want to point out that these systems with this type of style didn't have all that high of a failure rate. My first exposure on this was I was on 2012. I was doing an inspection for an insurance company as a contractor, and really one of the first solar systems I've ever seen. And we were noting that we were just shocked that these L feed were not, traditionally flashed in place, but yet were successful. This system was probably over 10 or 12 years at that time. And I even believe, talking to some of the old timers at the MREA fair last year, some of the pioneers, there are still these systems that are actually out there still. So as long as they were done quality products and done well, they lasted.
Yeah. And then the joke I like to always talk about is when I was doing these on cedar shake roofs, we won't go down that road because I don't know. Yeah.
A whole different beast.
A whole different beast. Yeah. Watching those things split as you torque them down. And yeah, anyway, we'll move on from that. And so then kind of in the evolution of doing, PV mounting on roof systems, we saw a lot of these OD type flashings, and it was one of those that the pipe standoffs that were popular again. So this is probably, still early 2000s. This is maybe a couple years later, 8, 9, 7, 8, 9, maybe around those kinds of times. But we had these pipe flashings look a heck of a lot like a plumbing vent. So let's flash them like a plumbing vent, and it makes a lot of sense. But as you can see in this picture, it requires that you cut the flashings. You have to slide, you have to use lag screws to get into the rafters. You have to slide the flashing underneath. Again, presumably this is not a brand new roof. Of course, that was an option as well. If you could get in and put those, I remember talking to a lot of customers saying, if you can get those pipe standoffs down before the roof goes down, let the roofers roof around them, and they know how to do that. And that was great when it was an option, but it's obviously not very much an option.
Right.
And so this was actually how I learned to install solar in Southern California, and was considered definitely the best practice to avoid any kind of roof leak with 100% pull proof, right? We also used a roofer to come in and put those standoffs in for extra validity. So not a cheap way to do things, but definitely was part of our shtick, was around being the safest method.
Yeah, this is a great example of the evolution of flashing, right? What we're talking about. So we went from a seemingly very simple and secure situation to basically, okay, we need to start looking at how other industries are doing this, and we need to adapt to their code. And that's just a great example of that, pipe flashings, especially to get away from possibly issues down the road. The pipe flashings were seemingly the solution. But as you mentioned, they were a little bit more difficult to use. a lot more detail needed, and not just any single person could go up there and install pipe flashing correctly. So even though it wasn't a step of furthering the solar industry to be more code accepted, it actually added a bit of hardship by actually having to elevate everyone's skill sets to be more of a roofer than a solar installer.
Yeah,
exactly. And as we're all trying to scale and grow and meet demand, this becomes less and less attractive. So trying to find methods that are still just as safe as this, but
Right.
Easier to do.
Right.
Absolutely. There was evolution of pipe flashings in itself, such as this next photo with the elevated block of the L-foot. This particular flashing I remember coming out, and the big thing was, we're trying to stop the top water from possibly going into the lag hole that we made, which is a good concept. But there's other places, of course, where metal flashings can be susceptible. But this certainly is, in my opinion, a step up from the standard food flashing. You're no longer relying on that EPDM seal, which over time do fail. So this was actually a pretty good evolution of the metal flashing itself, in my opinion.
Yeah, and this became, I would say, became what it has been known as the gold standard, and we are, and we'll talk about what kind of what that next step is. But this is, when manufacturers came out with this, again, this was applying roofing best practices as we knew them, as we in conference with the roofing manufacturers associations and things like that. And, how can we best do this? And this was considered that way. And so we're still seeing a lot of these. And this was, I was joking with Mike and with Joe prior, about kind of drinking the Kool-Aid, if you will, of this was, but it wasn't, not necessarily in a bad way. And it's not that the manufacturers of these products were trying to, do anything shady or anything, but it's, it became very much accepted as the best practice for the installation methods.
Absolutely. And I absolutely agree that this is a step up and more specific to solar than just your general pipe flashings. Pipe flashings are good for one thing. Bringing this type of flashing is specific to us, specific to attaching L-foot, specific to attaching a non-pipe. So by all means, this was definitely the right direction in the evolution of flashing specifically for solar.
And there's a lot of different flashings that have similar concept and yes. Variation.
Yeah, definitely.
Absolutely.
And then kind of brings us to almost, present day, if you will, which this looks a heck of a lot like, what it was where we started here in the early 2000s. And so these are some roof tech products specifically. And this kind of gets to the crux of the, what we were talking about, the topic, flash or not to flash, and how do we define flashings, as we talked about before. And so this is one, and quite honestly, because I had spent so many years looking at the flashing methods, as there's, Roof Tech is not the only manufacturer out there with this type of solution. And it's becoming more and more prevalent, I would say. And it was one of those, like, kind of got me scratching my head. It's like, have I been wrong all these years? What is, and so I don't think it's necessarily wrong. I think it's, as we'll talk about later, it's somewhat application dependent as well. And so, but here we are with these applications where some people call them flashless, or I think Roof Tech, I think you have a different term, maybe integrated flashing or something like that. And so using this method is kind of where the evolution has led us.
Right. Right. So, I had a similar experience actually outside of the solar industry. When I mentioned I first saw that direct L-foot to shingle in 2012 when I was a contractor, I wasn't even in the solar industry, but yet it kind of opened up my eyes to some of the issues I was having. To have a new contractor, a new roofing person come in and try to teach them how to do a traditional flashing properly, and struggling with that because it's kind of a mix between art and skill. And, of course, with roofing, it's the only method that we were aware of at the time. But after seeing this L-foot project and how long that it had lasted under that case, it opened my mind to non-traditional flashing methods. And the more I looked into that, I was finding things in the roofing industry, such as EPDM seals or butyl specific seals, that we were replacing a lot of things with, such as chimney flashings, which was a difficult thing to do with step flashing and counter flashing, took a lot of effort. But finding similar products that solved this problem that were accepted by the industry was mind-opening to me. So then when I was looking into solar itself, 5-6 years later in 2016, 4 years later in 2016, I was looking around and I had saw this small company, RoofTech, in Colorado specifically. I was at a solar show, and I saw that they had a butyl attached mount. And I was like, well, there it is. That's exactly what I had myself experienced, the traditional metal flashing to a butyl-based flashing or a top-down type of flashing. I signed right up, because this is, in my mind, is the ultimate solution that is mixed between proper installation and ease of use. And that's where they come together. The reason why, in my opinion, I don't know, because I was around 30 years ago, the reason why these guys were doing direct L-feet to roofs is because they were not comfortable tearing open the shingles and putting in a metal flashing. They didn't have that education. So I think that this full circle kind of brings it back there. Now, we're obviously not just caulking L-feet down to the roof. We've stepped it up a notch, and we've taken the butyl flashing mixed with our screws to create the alpha seal. And also mentioning the code standards, we actually did get this method certified as flexible flashing through the ICC, which is the umbrella corporation over the IRC and the IBC. So the product itself has gone through those certifications, but you never know, Ryan. Maybe back in the day, if someone were to approach the ICC with the L-foot direct goop down, that may have also tested well too. Like I said, that was actually a decent solution. But yes, so
yeah, and I remember there being not plenty, but they're having some, integrated butyl on the L-foot. And so,
yeah.
But again, that was, I think, kind of went by the wayside just through.
Yeah, and I'm not going to say it was an easy thing for us to come here in 2012 and say, hey, here's something new and different. Now, the difference for us, of course, is that we've already been doing this since 1994 in Japan. So we had a lot of data and a lot of testing to help us with that. But on the surface of things, it looks like, wow, well, how could this work? When you look at how complicated the metal flashing is, like, well, how could this peel, stick, and screw product be the same? And actually, according to tests, it's better. But of course, we can have that conversation later. But yeah, it's full circle from where solar started.
Sure. Yeah. This looks a heck of a lot like where we started.
Right.
Cool. So that was, and as I mentioned, we had our fun, could have gone down the rabbit hole of the not so good stuff. So Mike, if you want to just kind of talk us through a little bit here on kind of roof tech through the years. You had mentioned the stuff in Japan in the 90s, and so for those that maybe aren't familiar, a little bit on the company.
Sure. And I feel. Oh, go ahead.
Sorry. And just one more thing. I mean, part of the point here is that we are learning from more experience and more data, right?
Right.
So yes, the flashing methods have changed. The methods in all of solar have changed over the years, but it's never because we're trying to do something wrong. It's always because we get more information as we grow.
Absolutely. And I definitely pride Roof Tech as being more of an educator than anything. And that is just basically sharing what we have learned over the past few decades of trying this method out. And as you see on the screen, this method actually started for us in the 1990s. In 1994, we started to develop this method. Over the course of 4 years of small scale testing and internal testing, in 1998, we actually started to partner with Sharp in Japan, who used our product fully. And then by the early to mid 2000s, we were actually about 70% of the overall attachments in rooftop solar in Japan. So most people don't know that we actually came from that experience. And honestly, I'm still meeting people that don't know Roof Tech at all. So it is a great chance or an opportunity to explain that even though this technology might seem new to the United States, we've been here since 2012, so we're going on 10 years. It's actually much older than that when you look at a global stance. So really, that's just it. And about to 2012 to present, that's all of us being in the United States, and we got about 30 million or so penetrations. But we started as an R&D company and an installer ourselves, and then worked into basically trying to find the best method. And I can gladly say that our method of attachment, the butyl mixed with screws, has not changed since the mid 90s.
And you had mentioned too, something I didn't know before was that Japan had such a big push for solar in the 90s.
Yeah. Right. So just like California, they did their 1 million roofs push. Japan did the same thing in the mid 90s. And that's actually what kind of prompted our roofing company, Yannick, our parent company, which is a roofer components manufacturer, as well as an installer. They got into solar during that push. They saw the opportunity to bring what they were already working on to make roof systems nice and solid and clean to the solar industry. So that was definitely part of that push. Oh, I see a question here real quick. Which ICC standard? You can check it out on our website. We are certified for low slope, high slope, asphalt, metal, and single ply membranes as a flexible flashing. And I believe that is the ESR 3575 definition of flashing and application. But we do keep that on our download section of the website. Oh, thank you, Tracy.
Thanks, Tracy.
Yes. So a little bit more about our technology and our seal. As Ryan mentioned before, and we're happy about it, that other manufacturers are getting into a non-traditional flashing, checking out themselves how that they can make that ease of use with proper flashing mixed together. So I'm glad to see that and have that, but this is how ours works, which hasn't not been duplicated by others yet, patented of course, but we mixed two products together to create our seal. We utilize a butyl compound, which is proprietary to us that we've been using since 1994. And with that, we use a double helix threaded wood screw, which is also patented to us. Between these two products, we create the Alpha Seal, which is good for both deck or rafter attachments. The question I get all the time is, why don't you guys use monolags, which is the traditional monolag through the rafter? And there's a few reasons for that. Number one, we wanted to create a product that also utilized deck attachment as well as rafter attachment. And also two, one of the biggest problems in the industry is proper lag placement. For those of you who don't know, a lag bolt has to maintain that middle 30% of the rafter to achieve structural viability and not cause additional damage to the rafter. So this image here I'm showing with our wood screw going into a rafter, the red zone is the equation of the 1.5 the diameter to the edge, which is the stated code regulation for how much meat or where that bolt or screw can be located. So by reducing the size of the shank, we allow for less mistakes, as well as we take away the number one source of leaking in the United States, which is unflashed pilot holes. Very common mistake, very easily corrected. But we found out that we can get the same structural values out of two of these wood screws as we do a single lag bolt. So we just get rid of it entirely. Not a problem for us. So no pre-drill, no pre-caulking, does less damage to the roof and has more availability for deck attachment and rafter attachment.
I can throw in an anecdote there from being on the roof and how at one point my crews were doing several pilot holes as a practice. Even if they thought they hit it the first time, they would hit at least 3 to make sure that they were getting in that zone correctly. But then they're ending up with extra holes, right? Which always really bothered me. But the thinking was that it would be covered with the flash and sealed.
Right. And it's absolutely fine. And that it truly is the way to find the center. And there's a couple new tools that have come out recently that make this a little easier to do, but it's all about properly sealing those holes. It's not just covering with the metal. You actually have to caulk the hole, make sure the black membrane paper is sealed, and the shingles and the metal are all nicely sealed. So it's not, if it's not done properly, that's where you come into the issues.
It just adds more reliability each hole you do, to me.
Right. So we always had this thing about, roofs that we say it's not necessarily about the quantity of the penetration, it's about the quality. Roofs are meant to be penetrated. That's part of the system, there's there, but it just has to be done correctly. A couple cool things about the butyl that sets it itself from the standard caulking that's typically required is number one, it's temperatures of reliability, -40 degrees up to 250 degrees. It's pretty outstanding to where the product does not fail, will not harden, will not crack, is UV resistant. Also, too, it can be installed below freezing temperatures, which is really cool because of most of your caulk tubes and stuff, it's very difficult to install below 32 degrees, also possibly voids the warranty. One of the things as a roofer back in the day that we found out and learned was that typically install for asphalt shingles need to be done at 50 degrees or better. So when you're up on the roof and you're tearing apart shingles below 50 degrees, you're possibly causing issues. And that was always a concern for our parent company, Antigeekin, is they wanted to maintain, how do we keep the integrity of the roof causing minimal damage while also being strong enough, thus the top-down attachment.
Peeling back those layers in freezing temperatures is always really dangerous. And then on the flip side, in super hot temperatures, dealing with roofs and where it's all melting.
Right. Simply walking on a roof on a 100-degree day, you're just tearing those granules up. So anything that can be done to help protect the roof is the #1 goal of the solar installer, because if there's a problem on the roof after you're done, you're getting the call. No matter if it was you or not, you're the last guy. So it's definitely something that we can make sure that we try to keep the integrity. Also, too, as I mentioned, the butyl is universally attached. Unfortunately, Ryan, we don't do shake roofs, but we do pretty much everything else. So where most companies have different flashings for different solutions, we really do have one solution that's going to cover about 90% of those applications and certified to do so. And if there's ever a compatibility issue, for like a new products that come out, we always take those calls. We got a really good R&D team that will help you identify application.
So metal and comp are both the same product and the same, they've been tested and certified because they're very different.
Correct. Yes, they're very different. That's a good point. So most people are creating two different solutions, but actually our butyl seal is applicable to any type of roof except for wood shake, PVC vinyl as a chemical incompatibility, and direct to concrete. Now, there's a few other things that can't be installed on just because of profile differences. You know, we have a large base that needs to be put down. And if you have profile differences that outside of shingles, because we have handling that, but anything that has an air gap below the roofing surface is kind of a problem for us, because then you actually have to open that up to make sure that's all sealed. So air gaps below the surface, whether that be a gap in a metal shingle, or whether that be a gap in a single ply membrane, that's one of the biggest no-goes for us. But actual adhesion and waterproofing to the surface is pretty much universal. So it's definitely one thing that sets this technology of the butyl and the screws apart from most.
Great.
So we've been talking about standards quite a bit. And I think this is a good slide, Mike, around some of the different ways that this solution kind of varies.
Right. So, you know, we heavily tested from that 94 to 98 time frame just to make sure that we were going to be bringing a product to market in Japan that was going to be viable. You know, we knew that butyl worked. We knew that butyl worked in many other cases. Engine blocks, telecom, satellite, you know, they were using butyl across the board, just not specifically to solar. So one of the tests that we actually did internally that does not come with a certification, it was literally a test that we had specifically found a machine to do so. This machine was called a carbon arc test. This carbon arc test simulates, sorry, I'm getting to my notes here to make sure I don't mess this up. So this carbon arc test simulates in a controlled environment, 313 days or 7,500 hours of 145 degrees with constant UV light with 50% humidity and actually being sprayed with water for 18 minutes every 2 hours. So it's a really long test. Like this test takes 750 hours. I'm sorry, 7,500 hours. It takes almost a year. And these are the results that we periodically checked. And what these results here are really showing, it's kind of hard to tell what's going on here, but you see on the right side, you'll see our butyl directly connected to our base. And on the left side, you will see a sealant that was applied on top of the base, because we wanted to make sure, is the butyl going to be okay by itself, or do we need to add a sealant? And this is the result. So what we ended up finding out was the failure rate of caulk, which we all know caulk has a lifespan, and the more that it's exposed, the more that that lifespan is decreased. But what we found is that after the 7,500 hours, this particular caulk we used actually started to crack and become hard. So in that sense, the whole idea of caulking is that it's basically waterproof because it's flexible, because it's malleable, and it's able to move with the system. Once it becomes hard and cracked, it no longer achieves that waterproofing ability. So if you look over on the right side, the only thing that happened to the butyl is that it's slightly oxidized, but you could still put your fingernail right in through it and it's still soft. So the butyl actually has a self-healing quality. That self-healing quality allows it to be malleable through the life. And that's up to 250 degrees before that malleability actually starts to degrade the product. Now, this is huge for a lot of reasons. Beyond this test, this was just simply UV and moisture but we also learned that this product can actually help a lot when it comes to expansion and contraction and molds to fit around the movement of our lag screws, which was phenomenal discovery for us. But yeah, it's a great test.
Sorry, just a quick question. How long has it been tested for? So there's 7,500 or 7,500 hours, but how long is the longest that the butyl has been tested for? And what's your warranty?
Great question. So we actually have test plots up since those mid-90s, 96 to 98. We have test plots that are still up, and those test plots are outside. So this particular test was a controlled environment. The test plots we have outside are by the seashore and up in the mountains. We wanted to get the high winds and salt spray, as well as the heavy snow loads. So we have product that's been out in the field for over 28 years that we periodically check and update. And we offer a 25-year warranty, which we've actually surpassed with some of our original products.
Okay.
So another thing that we're really concerned about, the next test that we did was, of course, water permeability. Now, if we're saying that our product is going to be good on flat roofs, then we need to make sure that our product can be submerged underwater, because as much as we all like to think that that doesn't happen, it does. So this next test here is a 5-inch water column test over 30 days. So on the top picture, we have one of our old bases still utilizing our butyl with screws that's put on the very worst spot of a shingle. Now, of course, this is kind of above and beyond. You don't really use shingles on low slopes and they would never be submerged, but let's think of it maybe as like an ice dam to where it could happen of that nature. So anyway, we put the base down on top of the worst spot on the shingle, which is the crossover between shingle layers. Make sure we added in our extra butyl as we dictate in our manual. We put our tube on top of it, filled it with red dye, 5 inches for 30 days. Then we removed the tube, drained everything, and then checked on the bottom, which is those the lower 2 photos, which show that there was 0 penetration. So this is also an in-house test. The next test we did, which was the ASTM 2140, you can show those pictures. This is what the test was recreated to get the standard in the US. Now, because we have such a different type of product, we actually had to create a lot of tests or adapt a lot of tests. As Ryan was mentioning earlier, we don't really have any industry-specific testing or specific codes. So RoofTech is kind of on the forefront of that. We're always pushing the limits of what can we do to make sure what we are, what we want to happen is actually happening with the product quality and what it's able to do. So with that 5-inch water test, how we were actually able to actually get a code standard ASTM 2140 is a low slope metal roof permeability test, which just puts in a water column, I believe 6 inches for 6 hours. Yeah, that's correct. So it's a static water test, 6 inches for 6 hours. Now, if you look closely, you'll see these white lines across the shingles. And this was actually had to be done because shingles are not waterproof. Shingles are a water shedding product, which is why they can't be used on low slope. So we actually had to modify this test to seal the shingles tight, so it didn't allow for any water penetration, and then do the static test of 6 inches for 6 hours, which we of course passed. But now we maintain our ASTM 2140, which you don't find very often for a racking company to have, especially for a non-metal attached product.
What slope was that? Do you know?
So typically these will be a 0.05 slope at their lowest, but they could go up to 0.2. I believe this one was a 0.05.
Wow.
So basically the lowest slope typically that a membrane roof or a metal roof should be at. Right. Now, so this is just some of our tests. Oh, go ahead, Ryan.
I was just going to ask. So you're saying you're modifying that ASTM test. Did I hear that right?
Yeah. So this test was performed, I believe, by IBT. So this is third party. So
okay.
we did a lot of testing in-house, and then we had to basically get certification through third party. So we worked with companies like IBT and UL to help us adapt test to get that standard. So this one was originally designed for low slope metal that we adapted to an asphalt roof.
Okay. So kind of getting back to the original, like early thing that we were talking about without the industry standards, without the industry having
right.
to make those adaptations, I should say, to other standards to be able to test these.
Absolutely. Absolutely. And this was just one of about 14 categories of tests that we've done over the years and have been certified in.
Okay.
Okay. So this is kind of like the evolution of our latest products. I always like to point out that RoofTech came to the United States as a railless racking company. Probably one of the only railists. Well, I don't think we're the only ones, but definitely one of the only ones that was utilizing a non-traditional flashing. So the picture you're looking at, the RT Apex, is actually our third version of the Apex or of the railless system. Each time we gather information from our installers, the best place to make R&D is to actually talk to the people who are using the product. And we adapt it to the needs of those products, such as universal clamping, slide-in mounting, so you're not putting additional pressure on the glass, additional wire management, and especially leveling. Those are all basically the main things with railless that made them a little harder to deal with than your traditional rail. So this is the third version, and actually we are already talking about our fourth version to make some slight changes. But what I want to point out is that our actual flashing has not changed. That's the only part that we actually keep. Everything from the flashing up, we continue to modify to meet the changes in the industry. As everyone knows, things change fast. One of the most recent things that we all had to adapt to was the change of the 30mm module, the frame thickness, kind of unheard of before. And then all of a sudden it's like, well, I think we could fit more modules on a container if we make them smaller. So that was one of the most recent adaptations we had to make when it comes to the mechanical side of things. But there's all kinds of changes over the years. And then next over, we have the Mini 2. So when we came to the United States as a railless company, we didn't do so well, but we had this awesome flashing. So we adapted it to the rail and created mounts that could adapt to any L foot. And that's really what kind of pushed RoofTech forward in the industry to gain market share, was adapting to what installers preferred at the time, which was rail, which I'm happy to point out that that's slowly starting to change. There's more and more people looking at the benefits of railless now. And then lastly, this is a product directly we brought in from Japan. It's a simple roof entry bracket, or we call it the REB. This is basically a way for you guys to penetrate into any type of roof that has a pitch of 312 or higher, which includes metal, to bring in as a pass-through. But this is not a combination box. You can't do any wiring in here. It's just a pass-through. So those are the three main products that we offer today. And we'll be announcing some newer products coming off later this year or next year.
Great. So this REB, I mean, it's somewhat like an LB of some, like it's just
that's a great way of putting it. That's how I like to describe it. It's basically just a flashed LB.
Okay.
Which is great for certain scenarios, but of course, if you got to do some combining or wire transfers, you got to do something else.
Of course, yeah. No, it's not going to solve everything, but
right.
Interesting.
Yeah.
Well, cool. Well, we got a question from Ian, and so I'm going to just read this off. And so Ian's asking, compatibility charts generally available online show butyl and asphalt are considered to have unsatisfactory compatibility. What data does RoofTech have to that these are in fact compatible?
So actually, the majority of our research defines that there is no incompatibility of butyl and shingles and butyl and asphalt. More or less what we do find is EPDM actually has some incompatibilities or chemical incompatibilities with asphalt. Butyl actually used to be used in asphalt products, but then the rumor was that because of price, it was taken away. It's essentially an oil-based product itself. So actually, RoofTech stands behind the fact that there is actually no butyl to asphalt incompatibility. But Ian, if you have something you want to specifically send me and talk to me, I would love to have that conversation. But we've definitely been researching this for about 2 decades. And we don't find any incompatibilities, especially when it comes to our field sites.
Great, thanks.
Good question.
Okay. Well, we're getting close to the top of the hour. So if folks have questions, please fire away. Happy to hear them, answer them best we can. But yeah, some of the some of our key takeaways here. And as we talked about at the top, codes are ever evolving. Our industry is ever evolving in terms of sometimes we as an industry, we're ahead of the codes. As we talked about, when we started installing solar, there wasn't really codes that we could point directly to. And this is how we do it, both electrically and mechanically, really. And so staying up to speed is important, and finding ways of integrating these new products is an important thing for the industry as a whole. And then our evolving best practices, constantly learning as we went through all those slides or all those pictures. We're constantly learning from what worked, what didn't work, how can we improve on those things, and with a focus on quality. I mean, best practices is exactly that, right? Trying to focus on the quality, and how can we make these systems safer and last longer, install faster, quite honestly. So we're not just cutting corners, trying to do all those components. And then this flash or not to flash, the flash better. This is one, again, I'm not gonna lie. I mean, this is for many years. I was out there, telling people flashing is the way you have to do it. And I feel like I'm just now learning a lot of these things, about how maybe there are different ways. But I think one of the big key takeaways for me on all this is this industry specific testing, or this industry specific, the need for this industry specific testing. Because, I think one of the things people will say is, if you're taking existing standards and things like that and modifying them, then there's maybe something not great about that, or there's inherent
That's valid.
Less valid, or inherent maybe liabilities or something. Whereas if we're building it from the ground up for a specific industry, for a specific application, that would be much better. And obviously that's a lot of time, a lot of it's not something that just happens, and it's going to take manufacturers, it's going to take roofing companies, it's going to take a group of stakeholders, quite honestly, that are dedicated to doing it, and probably years, quite honestly, I would expect, in order to make that happen.
Yeah, and I think that the industry should be demanding that in some way, shape, or form, because otherwise it won't happen, right? So that is one takeaway for me. And then as far as flashing better, there are a lot of different methods, and there's a lot that will work just fine and protect your homeowner for a long time, but being trained and following the proper method for how to use each of those attachments is key. So sometimes I think it can be detrimental when you have a crew that has 10 different flashing methods in their repertoire, because it's hard to keep track of exactly the proper methodology for each, and there might be crossover that isn't accurate. So
right.
I think making sure your crews are well prepared and trained to do what your chosen method is.
I can't speak to that enough. Reading the manuals, talking with your reps about knowing your product and how to use it inside and out. I'm guilty of this myself. When I get a piece of IKEA furniture, I just put it together. Usually end up a lot of mistakes. So I myself am always one to go back, read the manual first. It's not something I was born doing, but in the end, it's absolutely what needs to happen, not only for your company's liability, but for the homeowner. Absolutely have to make sure that you're doing everything by the book.
Right. So as an operations manager, or as somebody making decisions on what products you're putting in the hands of your crews, you need to, if you are changing your products, which I don't think is a bad thing either, because things evolve, you need to make sure that your crews are prepared for that change.
Absolutely.
Yes, we don't have any more questions. I'm glad to hear about the CALSA momentum.
Yes.
Yeah, yes, I guess, Mike, do you have any info? I mean, people probably can reach out to CALSA. Do you know who at CALSA or what? So if there's a specific group?
I actually encourage everyone to reach out to Milton Nagara on our team. He's the one who's directly handling this. He's currently in Hawaii right now. So I meant to talk to him about the more specifics of that. I just get reports from him on basically right now they're working as a kind of a think group to basically collaboratively start to define things like flashing and attachments. And I believe that CALSA is the one organizing that in the effort we can help that change that codes and standards. But Milton Nagara from our team is definitely the point contact that he could be a lot more informational on that.
Great.
And Tracy, if you're listening, if you could put Milton's contact info, if Milton wouldn't mind, I don't know.
It would be fine. He would love to talk about it, to be honest.
Just if there's anybody listening that would be interested in participating in the conversation.
Yeah, absolutely. And that is something I can't say enough of, that now that we have a lot of manufacturers looking into this different approach to flashing and creating their own ways, we really all need to kind of work together to help define and create a proper definition of what this is. Now, luckily, Roof Tech has done pretty much all the legwork to make sure that the AHJs in the country over the past 5 to 10 years are now familiar with this type, but yet we're still battling some specific areas that perhaps are not, or well, they're just perhaps looking at specific code definitions that we have the ability, or hopefully have the ability to update as the industry.
Yeah, I think just making it perfectly clear through a standard
Right.
will help everyone,
Yep.
right, across the board. So hopefully we'll get there soon.
Absolutely. I hope so too.
But in the meantime, it's nice to hear all of the different testing and ways that Roof Tech is trying to, shore up all of that data and make sure that the integrity is there.
It's our diligence. I mean, no one on my team wants to sell anything that we know is not going to work. And we certainly don't want to create any new products that we know are not going to work. So it's very important to us to maintain that product quality integrity. Honestly, there's a lot of products we don't even bring to market until it makes it to a certain point of testing in our own site.
I remember Joe actually mentioned something about that all of the products are tested prior to going to market.
Oh, yeah. No, we wouldn't do it any
Everyone.
other way. So like all those tests that you actually saw on the previous slide, those were done before the product was actually in market. And then, of course, we are always updating these tests. It's very key for us to do so. Now, luckily now with changing of the, with not changing the butyl and the screws, we pretty much have run through all the basics. So we're not really doing any more new butyl tests, but new butyl certifications. So like, for example, the new ICC report that we have, we updated it to include metal, low slope, high slope, and EPDM. We already knew that the product was capable of doing so. We tested, but the certification wasn't actually achieved until just this year, just because we hadn't taken that extra certification step. But yes, you can absolutely trust that anything Roof Tech puts out to the market, you're not going to be the first ones to use it or the first ones to test it.
Well, very good. So all of our contact info is here. So if anybody has other additional questions, wants to reach out, anything for Mike, Laurel, or myself, please do so. Mike, thanks so much for the time. Really appreciate it. It's like I said, it's a learning process for me as well, and so it's good to keep staying on top of these things. And Laurel, thanks for joining us and helping bring your perspective.
Sure.
Thanks, Ryan.
Thanks.
Thanks, everybody. Appreciate it.